Okay, we're going to talk about grease, how it's made, what's in it. The first thing I want to say is, why do we use grease and not oil? One obvious reason is that grease stays in place. You don't have to worry about it running down onto the ground most times. The other thing is that you can put a lot more stuff into grease. Whitmore has a product that has 40% graphite in it. You put 40% graphite into oil, it's going to float to the, or sink to the bottom right away. So that's why we use grease. Obviously, in a rail curve situation, it's much easier to get grease to stick and carry than it is oil. And the first thing is, well, what is grease compared with oil? What's the difference? Grease is oil with a thickener, and the thickener holds it like a sponge holds water. That's the primary difference between an oil and a grease. Most of the thickeners used in grease are soaps, made very similar to the kind of soap that you take a bath with every day, but not sudsy. The primary worldwide thickener for grease is lithium soap, and it's made by reacting a fatty acid with an alkaline or a base material, and the end result is a soap and water. Then we continue to heat the grease until the water is evaporated. That gives us our soap. We then move that from the soap mixer over to the grease mixer. We add the oil, we add the additives, we homogenize it, smooth it out, and package it, well, screen it, and package it. Some of the stuff that goes into grease, obviously I've mentioned the thickener, and I mentioned the oil. There are various kinds of oil, including various synthetics. But we're going to take a look at some of the actual materials that we would add other than that. Here we've got three different kinds of polymer. Polymer is essentially just a plastic material, very like what your patio furniture would be made out of, maybe a little bit softer in most cases. It has a lower melt point, so that at the kind of temperatures where we mix grease, this stuff will melt into the grease. This is one polymer. This is a slightly different one. This is a little bit harder. And this third one that looks like sugar is harder again. So you've got different grades for different needs, and what the polymer gives you is body and stickiness. Once it melts in there, it makes it more tacky and sticky and water resistant. Polymers are very important in rail curve grease. Oh, by the way, I forgot to show you this. This is an actual sample of rail curve grease. This is lithium soap that would be used in rail curve grease. Nothing very special to look at. When we think of soap, we usually think of a bar of soap or liquid soap. This is somewhere in between. It has a greasy feel to it, just a little on the stiff side. We actually do make the soap with a little oil so that it's pumpable and you can get it out of the mixer more easily. Just a little to get it in the consistency that we want. Now, some of the materials that we know about, molybdenum disulfide or moly. This stuff is as fine as talc and extremely smooth. You can see that it just leaves a kind of a gray sheen on my finger there. How Moly works is this. Each of these tiny particles is laminar. It's composed of layers. And if you could imagine a room covered in decks of cards, because each particle is almost like a little deck of cards. If you can imagine a room covered in with decks of cards, and somebody rushes in, he's going to slip and fall. But if a lady walks in with stiletto heels, like my cinematographer is wearing right now, no damage will occur to the floor. So you're protecting from wear, from pressure, and you're also creating a sliding effect by this laminar effect. Moly is particularly effective that way, but it's also very expensive. A less expensive alternative is graphite. Again, you know, you run your finger through graphite, you wouldn't be able to distinguish it from moly. It has a similar look, a similar feel, but it is one heck of a lot less expensive. Me being a bit of a miser, I like using graphite and lots of it. You also need extreme pressure and anti-wear additives in grease. Anti-wear additives operate at lower pressures to protect from wear. The extreme pressure additives kick in at a higher pressure and temperature. This happens to be an extreme pressure additive. It smells kind of funny, a lot of them do. It's very thick. It has to be added at a certain temperature in order to melt into the grease properly. And by the way, it takes 2 days at least to make any grease, sometimes 3. So the process is long, lots and lots of mixing, lots and lots of homogenizing to get the stuff smooth. So this is not just like baking a cake that you can do in a couple of hours. Another substance that's often put into grease, including rail curve grease, is a tackifier, which itself is a kind of polymer. This is a really bizarre material when you buy it. It's a kind of a gel. It flows like a kind of soft jelly. And as you can see, it's extremely stringy. It also smells a little funny, but there's that string. Let's see how long we can make that. There's about a foot, foot and a half, 2 feet still going. Oh, okay, that's as long as I dare to make it. And this stuff is sticky. So that'll give you tackiness, that'll give you water resistance in particular, and that's responsible for what BNSF refers to as string. Okay, I think we've covered the majority of it there. We don't want this to be too long. Next, we're going to go to the lab, and we're going to look at some of the tests that are run on grease. Thank you. The most important lab test for grease is the penetration. And then based on how far that cone there drops down into a cup of grease, tells us how soft that is. Obviously, when it penetrates deeper, you've got a softer grease, and less penetration, you've got a stiffer grease. And from that information, the Nlgi grades are developed. So you have a 0 grease, which is a soft grease, a 1, which is stiffer, 2 is stiffer again, etc. Actually, the softest is 000, and the stiffest is a 6. These are the cups that the grease is put into for that test. And the test is run 2 ways. Unworked, so you just fill the cup and run it. And worked, which usually gives you a slightly different reading. What you do is you fill this cup with the grease, you put this cap on it. The entire assembly then goes into this machine that works at 60 strokes, and then you run the penetrometer. So you have 2 penetrations, 0, unworked, and 60 strokes. And the Nlgi grade is actually based on the 60 strokes. Working it gets rid of air and just homogenizes it a little bit, but primarily gets rid of air and stabilizes the grease, and that's the penetration that Nlgi is based on. Here in the corner we have a couple more grease testers. This machine here sprays grease onto a sprays water rather onto a panel of grease to see how much is removed by the water. It's called the water spray-off test. Over here we have a couple of panels that have been sprayed. They're now drying, and then they will be weighed again, and they'll measure how much grease was removed by the water. This machine here is, as you saw, this first test, the spray-off, is run on a flat panel. This is the water washout test. It uses a bearing instead of a panel, and you're doing exactly the same thing, measuring how much grease is washed out of the bearing by a spray of water. This is called the shell roll stability. These cylinders here, you put the grease in, these are extremely heavy, and inside the cylinder, oh, I can't get it. Inside the cylinder, there's a very heavy rod. That's assembled, placed in here on these rubber rollers, and rotated, and that very heavy rod inside the cylinder just gives that grease one heck of a mashing, and at the end, you measure how much change in penetration occurred between the before and the after. So you're looking for stability. Is the grease thickening up? Is it thinning out? It can go either way. What you don't want is a lot of thinning out. That's the worst case scenario. So those are the major tests other than the 4-ball. And the 4-ball test measures the grease 2 ways. One is the anti-wear ability of the grease. This would be for lighter duty greases such as bearing greases. And then there's the extreme pressure weld test, more appropriate for rail curve greases. And what you do is you load up the machine, and you increase the load in stages, and you find out at what load stage the balls weld together. And obviously the farther it goes, the higher the load it can withstand. In other words, if you have a weld point of 250 kilograms, that's not as good as 600 kilograms. So that's it in a nutshell. Grease in 7 minutes.